student plans an experiment to determine the focal length of convex lens by measuring the distance to the real image of an object screen. Part A. Before choosing the suitable value for the object distance, the student should know the approximate value of the focal length of the lens. How does he find the approximate focal length? We can find the approximate focal length of a convex lens by using a far object. We can observe a far object and we can place lens such that a real inverted image is formed on a screen by the far object. Then distance between lens and screen is equal to the focal length. It is the method we can use to find the approximate focal length. It is not 100% correct value. Then we can write answer for part A. Place the lens in front of a wall or screen to obtain a clear image of a far object and measure the distance from lens to wall. We can draw it like this. If we are considering a far object, light rays are parallel to each other. Then we can see that an image is formed at this place. If we are placing a screen at this place, we can see the clear object. Then this one is the focal length of the convex lens. In part B, taking the objective distance u, image distance v, and focal length f, write down the equation that the student is going to use in this experiment. We have to write the lens formula. 1 over v minus 1 over u equals 1 over s. In part C, rearrange the equation in B above to obtain straight line graph. We can change v value, u value, object distance. Then it is the independent variable, we have to get it in x-axis. V value is the independent variable, we can get it to the y-axis. When drawing a graph, we can get 1 over v and 1 over u value. Then we can write 1 over v equals 1 over u plus 1 over x. It is in the form y equals mx. Sorry, y equals mx plus c. X is this one, intercept is this one. Gradient should be 1. Gradient should be 1. Then part B. If the readings of experiments are plotted using the sign convention with proper labeling of independent and dependent variables, draw the expected graph of the space given below. We have to apply sign convention. When using sign convention, for the real image, object should be formed at this side, image should be formed at this side. We have to measure all distances from pole of the lens and distances towards light rays. It means in this direction should be minus. Light rays are moving from this side to this. Then towards light rays minus, opposite to light rays plus. When considering U, it is this one. It is a plus value. Then U is plus, V is minus. And we know that focal length of convex lens is always minus. Then we can apply sign convention to this equation. 1 over V value minus, 1 over U value plus, 1 over X value minus. Now I will change mark of all terms. 1 over V equals minus 1 over U plus 1 over X. There is a minus gradient is 1. It is in form y equals minus mx plus c. This one is x, this one is y. Gradient is minus, intercept is plus. Then we can draw rough sketch. It should be like this. Y-axis 1 over V, x-axis 1 over U. Then part E. If the approximate focal length of the lens is 12 centimeters, taking 16.7 centimeters as the minimum object distance and 100 centimeters as the maximum object distance, write down 4 suitable object distances in between the minimum and maximum. The length of laboratory table is 200 centimeters. You may use 0.167 into 6 is 1. We can get maximum 1 over U value. One over U maximum should be for the minimum value of object distance. 1 over U is maximum for the minimum value of object distance. Then 16.7 is the minimum value. 1 over 16.7. We can simplify it and get the answer as 0.06. It is the minimum maximum value. Answer then for the minimum 1 over U value, 1 over U minimum should be maximum value of U. They have given that length of laboratory table is 200 centimeters. We have to place the lens at the midpoint of the laboratory table and we can get maximum U value 100 centimeters because of total distance of the laboratory table is 200. Maximum U value 100, then minimum 1 over U value 0.01. Now we have to select 4 suitable values between 0.01 and 0.06. Then we can get 0.02, 0.03, 0.04, 0.05 as 1 over U value. Then we can get U value 0.0, 1 over 0.02 means 100 divided by 2, 50 centimeters. One over 0.03 means 100 divided by 3, 33.3 centimeters. 100 divided by 4, 25 centimeters and 20 centimeters. These are correct values we have to select when drawing the graph. Then part F, another student took U equals 12.5 centimeters as object distance and he could not measure and image distance give reasons for the proper explanation. If you are calculating d value by using given u value 12.5, v value should be a larger value. Therefore, we can't observe it by using the length of the table. Then we can get answer for part F. We can write when u equals 12.5 centimeters, v is a larger value. Therefore, we can't observe that value on the table. The laboratory table, length of laboratory table is not sufficient. In part G, complete the following diagram of the experimental setup, indicating both focal point, object pin, locating pin, the position of the eye and other important items. This is the lens. We have to place it on a lens stand. And we can place object pin like this. It is object. And we can observe image in this side, inverted one, therefore it should be in this direction. Therefore, we have to locate pin L in this way. And I is in this side. We have to draw a screen in this side to see object and images clearly. Now I will explain that how can we get the correct image distance. We have to place the eye in this side, and when the eye is placed in this side, we can see an image like this. An image like this. And we can use the locator pin to find the correct distance, because of this one is a real image we can see only through the lens. Then we can use locate pin. This one is the locate pin and this one is the image. We have to find the correct position of the image. When finding position of image, we can move locate pin along this axis while the eyes are moving in perpendicular direction like this. Then we can see that if locate pin and image is not coincided, those are moving with a relative motion. But for the coinciding position, those are moving without relative motion. Then we can identify clear position of image, and we can measure distance to locate pin as image distance, B, distance to object pin as object distance. The next one, part H, a student plotted the graph with 6 points by measuring 3 U values only. State the procedure that he has adopted to plot the graph and give reasons. We can interchange V and U values and get another 3 points. Then we can write answer for part G. We can interchange U and V values to get 3 another point. We can write reasons. Light is reversible. Therefore, we can interchange position of object and image.